Good day, students. Now we are going to see one important chapter in the moving charges and magnetism in physics. So, how the moving charges, magnetism. First we will go for magnetism. The moment magnetism means that comes to your mind is magnet, because magnetism is produced by the magnet. Everybody knows that. Now it's correlation between moving charge and magnetism. That means the charge that is moving producing the magnetism. So you can take in the simple when you were childhood you might have taken some some paper and some magnet and say put some iron particle, something like that, iron scraps if you put, and if you just move the magnet below the paper, what will do, the iron scrap will keep on moving it. That means the first here comes the magnetic. The magnetic attraction came here. So the ions will be attracted towards the iron gates will attract towards the magnet. So this is the initial start. This is only the initial start came. That means now the magnetism which is the magnet which is moving can able to pull the particle. That means so which particle it will able to pull the particle? Iron particle. If you put what is sand is made up of now, then another experiment you are performing it. Another experiment you are performing it, which is you are taking some sand, which is silicons. You know, right? Silicon dioxide. Sand is made up of silicon. Here, what is here? Here it is iron. What is iron made up of? Fe3O4. So this one is Fe3O4. That one is SiO2. So now you are taking paper and adding the iron particle to it and moving the magnet. Now the particle will move or not? Yeah. Now instead of that, in the second experiment you are taking silicon dioxide. Okay, and now moving the magnet. Will it move or not? Will it move or not?
Silicon dioxide. That means sand.
Sand.
Move, sir.
It will not move.
Iron particles.
Sand, no, purifying iron, but only silicon dioxide. Sand, from the, or if you want, you take from the sea. Okay, sea. Put that it's a pure form of silicon particle. Put it in the paper. Just take a few take a pinch of sand, which is silicon dioxide, and put it in the paper and move the bar magnet. Now the sand will move or not? Silicon dioxide will move or not?
Will not move.
Huh?
Move on. Sand.
Sand. No.
Sand only, sir, or sand or iron particles?
No, sand. Silicon. Only sand with silicon dioxide. No iron, because I am taking from the seashore. It will not have not even 1% will not have the iron. It's a pure form of silicon dioxide. So now I am moving magnet. So now the silicon nanoparticle, silicon particle will move or not?
Will not move.
Will not move. But here if it comes to if it comes to which is the pure form of iron particle, I am moving the magnet, it will move. So here comes the point. Here itself the differentiation comes. So what makes the particle to move here?
Iron particle.
Iron particle will attract towards magnet. But here it's a silicon particle does not attract towards the particle. So why the iron particle will attract towards the magnet and why the silicon particle will not attract towards the magnet? It can show, no? Why?
It does not have any positive or
No, positive is based on the magnet. If it is if north pole, it's facing the north pole, south pole. So like that it does thing. So if you keep irrespective of the pole, whether if you keep the magnet towards the south pole or north pole, it will attract. Only the differentiation is we are making the two direction. That is the which is facing in the with the two direction, which is facing opposite to it, it will come under north pole and south pole. So if you go for here, if a silicon particle will not show attraction. If whether it's keeping small magnet or very powerful magnet also, it will not show any attraction. It has no use at all. It will not show any attractive power. So if coming here, you can take if you take a small magnet, or if you take powerful magnet also, it will show the attraction. Why? Because That only I am asking, why iron particle is attracted towards the magnet, why the silicon nanoparticle, why silicon particle you can take, that is not attracted towards magnet. That's a question I am asking. Huh? You understand my question first. First you have to understand the question, my question. Okay?
It contains charges.
Huh? It can.
Iron particles attract to the charges.
No, it's not. This is a magnet is there. Is due to force of attraction between the electron, outer electron present in the iron particle. Force of attraction between the outer electron. Force of attraction between the outer electron present in the iron particle, that is not present in the silicon dioxide. That's all silicon dioxide. So the particle which is something, the particle which is showing attraction towards magnet means it has the presence of
Charges.
presence of charges. That is electronic charge. So it has to show presence of electronic external electrons, like external electrons. Okay, that is the thing. So in this series, if the nodes electron, so how will you differentiate these two now? How will you differentiate? That means it has the iron particle showed the force of attraction. Silicon dioxide does not show the force of attraction. So how will you differentiate this now? Based on magnetism. Presence of how will you differentiate it? How will you differentiate means that is the presence. It has showed due to presence of charges. Okay, charges. Okay, charges. We go second step. Before due to presence of electron. Everything is based on electron. Without electron, nothing will work. If there is that means the presence of unpaired electrons. So any unpaired electron is there, that is it will be negative charge. So the magnet should be positively charged. So that will show the attraction. Negative and positive will show the attraction. Now we comes for here silicon dioxide. So silicon dioxide will not show any attraction. That means
No electrons are present.
huh?
No electrons are present there.
Electron will be present there.
Positive
Huh?
charge.
See, electron will be present here, but it not show attraction towards the magnet. Huh?
Negative charge. Positive charge.
Electron will be present here. Then how will it be positive charge?
Paired electron.
Paired electron. That's really. This is what I teach you in the last class. All the classes I am teaching you. If the electron should be
Unpaired.
unpaired for the attraction. If its electrons are paired means
No attraction.
no attraction, because number of electrons present in the outside shell unpaired. There is no unpaired electron. All are paired. That means it will not show the attraction towards the magnet. So unpaired, and so this makes the difference. So when it's so now it comes the ferromagnetism and diamagnetism. Ferromagnetism means ferromagnetism means unpaired electron. Okay, it will have a high magnetic strength. And diamagnetism means no magnetism, because electrons are paired. So electrons are paired means it will not show any magnetism. So now I am taking iron particle and silicon particle. Now I am bringing the magnet towards. So iron particle will attract towards the magnet. Here silicon particle will attract towards. Will it attract towards the magnet? No. So the iron particle is made up of. Iron particle is
Unpaired.
unpaired. That only finally led to ferromagnetism. Here I am coming to silicon dioxide, which is unpaired paired electron. So it led to diamagnetism. So you taken all this point?
Yes, sir.
So you taken all these points?
Yes, sir.
how the attraction will be the magnet, how the particle, iron particle to the magnet, attraction towards magnet, silicon particle attraction towards the magnet. So all the things you have taken, no? Okay. So in this series now we go for source of the things. So source of the things is force of attraction. Force of attraction is force of attraction. Now we comes the point. Now we comes the copper. Okay. The copper when electropotential, if you apply the potential, what will happen? Potential. Electrons will move. So if the electrons are moved, what is the charge present in it?
Negative charge.
Negative charge. That is charge of electron, which is negative charge. So the magnetic field will be produced. Where the magnetic field will be produced?
Positive.
Magnetic field. Where it will be? Where it is produced?
Perpendicular.
Perpendicular to the electric field. I am taking this copper wire, applying the potential, and when I apply the potential, electron will flow. When the electron flows, what will do? It will produce the magnetic field perpendicular to the electric field. So then what is the angle between the electric field and magnetic field?
90.
90 degree. So F is equal to Q into I. So which is F is equal to Q into E. So F is equal to Q R by 4 pi epsilon 0 R square. R is the distance between them. Then it's the force. This force of attraction is called the Lorentz force. Lorentz force. So this force, the force and Lorentz force. The total force. The Lorentz force is given by F electrical and F magnetic. Lorentz force is given by F electrical and F magnetic. Lorentz force is given by F electrical and F magnetic. Okay. So F electrical and F magnetic, and this force is totally given by Q into ER plus V into B. Did I give this equation? Yeah, because what is E here? Electric field. Electric field. V is velocity and B is magnetism. So velocity and magnetism are perpendicular. So that means already electrical field and magnetic field are perpendicular. Now velocity and magnetic field are perpendicular means which direction now? You understand my concept? X
direction, Y direction.
Huh? So what is the direction of electric field, magnetic field and velocity direction? What is the direction of electric, magnetic and velocity? Just now we discussed electric field and magnetic field are perpendicular. So what is the angle between them? 90 degree. Now Lorentz force is equal to force of electrical and force of magnetic. Okay, is equal to Q into ER, Q into E plus V into B. Q into E plus V into B. Okay. This you can take if you multiply with charge, so it will be Q into E plus Q into V into B. Okay. Q is charge, E is electric field, V is velocity, B is magnetic field. Now V into B means velocity and magnetic are perpendicular. So now what is the direction of EVB? What is EVB? First, what is E? Just now you told, no? Electric field. What is B? Magnetic field. What is V? Velocity. So what is the direction of VBE?
E on the X direction, B in Y direction, V Z direction.
Z direction, correct. So all three are mutually perpendicular. That means VBE all three are mutually perpendicular, X Y Z axis. So based on this axis only, so this is so both are mutually perpendicular. Okay. Now next is, what is next? Magnetic force on motion in the magnetic field. So the motion in the magnetic field. So the moving charge, for example, so what the equation I gave? R is equal to P is equal to V
Vt equal to 2m pi t
Ah.
divided by q.
QB. So what is a Q? Q is a charge, B is the magnetic field, M is the mass, V
V velocity.
velocity. Okay. Then motion in the combined, and then what is the next topic? Cyclotron. No, okay. Cyclotron. Cyclotron. What is the purpose of cyclotron? Cyclotron is the one by which the any particle you take. Okay. Any particle if you take, what it has to travel with. What is purpose of cyclotron? Do you know what is purpose of cyclotron? First, what do you mean? What do you mean by cyclotron? Accelerator. Yeah, correct. Accelerator. Cyclotron is a type of accelerator. So, what is purpose of cyclotron?
Accelerate the charges.
Is accelerator is not charge? No. It will not charge is different from particle. It will accelerate the particle.
Electron.
No, it's a particle. It could be anything. We need some particles. It's not a charge. See, it's based on the charge. For example, what is electron?
Flow.
What is charge of electron?
Negative charge.
Negative charge. What is charge of positron? Positron. It will be electron, similar to electron, but you have a positive charge. Positron. Then what is neutron? Zero. And neutral. No charge. Neutral or no charge? Zero. Then proton and neutron. What is charge of proton? Positive. What is charge of neutron? Negative. Yeah. So what is charge of neutron? Neutral. Zero. Okay. So all are particle, but charge is different. It could be positive, negative, zero. Within 3 only it will fall. Now comes the cyclotron. What is purpose of cyclotron? So cyclotron is a one. You remember, right? How you produce that electricity in nuclear power plant? Kalpakam, or there is not a Kalpakam. Kudangalam is there. Then Bombay is there. There are in India itself 10 to 20 places in India. All over the world there are thousands of places is there. Kalpakam is, since you are in Chennai, I explained you Kalpakam. Then Kudangalam also is there. You know, right? Kudangalam near Kanyakumari. You don't know? You know Kanyakumari at least? Near that place Kudangalam is there. They are producing the 100 megawatt. Okay? Here they are producing the, they are producing 1000 megawatt. Here they are producing the 100 megawatt. Okay? So what is the difference between 100 megawatt and 1000 megawatt? Huh? High?
High voltage produce.
High voltage, yeah. Not high voltage. Number of production is more. That means I want more electricity. I want 100 megawatt, 1000 megawatt, which is almost 10 times. 10 times greater. So I will produce the current electricity almost 10 times. So that means what I want, then I need what? 10 times production is okay. What I need it there? Uranium I need it. So I should have enough material of uranium, then only go for power plant. If there is not any efficient uranium, what will happen? Yeah, no current will be produced. Okay. Now there is all over India power shortage. Entire South India. Why?
Uranium.
Not uranium is less.
Summer.
No, summer energy consumption will be more. That is not the answer. Throughout India now power shortage. Why? Throughout India. Not throughout India. South India I think. Throughout South, not Tamil Nadu, Andhra also. Andhra, Karnataka, Kerala, entire South India shortage money, power shortage. Why?
They don't have uranium.
No. Uranium is different. Huh? Less number of? What? Throughout South India there is a power shortage. Why? Due to, no, you are aware of or not? Due to coal production, shortage of coal.
Shortage of.
Shortage of coal. What they will do with the coal? Similar thing. See, you are taking, you want hot water, you can take coal, put it and heat the water and you take hot water, either for drinking or for taking bath, etc. So that's a hot water, purpose of the hot water. So when the hot water become vapor, what will happen? When the water become vapor, in the vapor state, what will happen? It will, when the fan blade is attached to it, what will happen? The blade will rotate. So from that we can produce the electricity. So from the coal you can produce the electricity. If the shortage is there, means coal shortage is there, means electricity shortage. So that's why now it's, this trend only going on. They don't have enough coal to run the they don't have enough coal to run the plant. What is the plant name? No, uranium is a heavy element. Plant name.
Nuclear power plant. Coal plant.
How we are producing the from the name itself we can get the thing. How we are producing the coal? From how you are producing, no, how you are producing electricity from the coal? How we are producing the coal? How we are producing electricity from the coal? By burn. What is the meaning for burning? Thermal. Heat, that's a heat. For supplying the heat, your water is converted into vapor. So it's a type of heat you are providing it. So it's a thermal power plant. This one is thermal power plant. That one is a nuclear power plant. And another one is uranium is a hydroelectric power. From the dam, the production of electricity is called hydroelectric power. Now comes the cyclotron. Now what is the purpose of cyclotron? Acceleration of the particle. So any particle if you take, I have to accelerate it with specific velocity. I have to maintain that constant velocity. For example, the velocity the accelerated. I am having that particle. Any particle you take, this is the room it has to travel. From the distance it has to travel from that point to this point. Okay. What is the distance between means? It's a specific, it has to travel with the specific velocity. Specific velocity means the starting point and ending point, the velocity, change of the velocity should be same. So then the change of velocity is equal to change of velocity. Zero, that's all correct. That means initial point to the final point, the velocity remains constant. So the change of velocity is zero. So the velocity should be maintained. If there is any small changes is there, then it will not work. So that's the purpose of cyclotron. This is the purpose of cyclotron, but where it is used in the cyclotron? Do you have any idea? I think I teach you, I think this one.
No, sir.
Cyclotron.
No. Cyclotron teach panninga, sir.
Definition, okay. Okay, so now we go for nuclear power plant. Okay, how you producing the electricity there? From?
Coal.
No, from coal, not from the coal.
Power station.
Nuclear power station. Uranium. Which uranium you will use?
Uranium 236.
235. For that, what is the another purpose you are using? Uranium, with that what you are using?
Dividing into 3.
Uranium 235 you are taking it. So with that what you are using it? From uranium 235. From uranium 235?
Producing energy.
No, that is producing electricity different. First it has to divide into
3.
what is it? The 3?
Chromium.
Barium,
Krypton.
krypton, energy. What is the main target now? Uranium. How the uranium is splitted? What is the name of the reaction?
Nuclear reactions.
That is a nuclear reaction. Nuclear reaction only. What is the time of the reaction? That is a nuclear fission. Nuclear fission. Then for that I am taking. Then for uranium to break into barium and krypton plus energy, what I am supplying? I am supplying a neutron, N01. N01 neutron. So if I supply this neutron plus uranium, this I already given in the nuclear reaction.
Atoms.
In atoms. So neutron plus barium plus
Krypton.
neutron plus uranium will give barium plus krypton plus energy. So that is only they taken as Yeah, that is only that. So now I have to travel. Now, so now this, this specific purpose, neutron. So how the neutron is obtained here? From where you obtain from the neutron? Neutron, N01.
By nuclear fission.
Nuclear fission is different. Do you have that paper? You take this atom and huh?
Nuclear.
Nuclei. Ah, it's in the nuclei, I think.
Adding one neutron to uranium.
Adding one neutron to the uranium. So what is the total reaction? N01 plus uranium 235 plus 92. Uranium
236, uranium 92.
uranium 236 92. Uranium 236 92. Uranium 236 is unstable. So it will divide it into stable product, which is barium, krypton,
Energy.
plus energy. Yeah. So that energy only they are using for the production of electricity. So what that energy will do now?
Supply
See, energy, how directly energy, from energy you will get the electricity.
heat energy.
Heat energy, it supplies the heat energy. From that, how will you get the electricity?
The fan is.
Yeah. That's what, that only I teach you, no? So the heat energy will boil the water. So water will convert into vapor. So once water converted into vapor, you attach to the fan blade, it will try to rotate. So once it's rotated, from that you can be able to create the electricity. So now in this equation, what is neutron? N? N10. So N10, because you need only one neutron to bombard one uranium. So that is can be done as cyclotron. Now you understood? Now you understood?
Where this neutron comes from?
That's from the cyclotron. They will send it from the cyclotron. So uranium they kept in the core, that's a core. Uranium they will kept in the core of the plant. And the cyclotron they will send it from the, neutron they will send it from the cyclotron. It has to travel with the same velocity. If the velocity is missed, it will not hit the uranium. Cyclotron is a device. From the cyclotron, they will send the neutron. Okay? So that neutron will travel with the same velocity or specific velocity. Specific velocity means what? It has to travel with the one velocity. The velocity should not change. Okay? So if the velocity does not change, so it will hit the uranium 236, uranium 235. So once the neutron is hit at the uranium 235, what will happen? It become first uranium 236. Uranium 236 is unstable. So it divided into its part like barium, krypton and energy. So this energy will be converted into electricity, etc., etc., etc. So the neutron is coming from which place? Cyclotron. So uranium is kept in the core of the shell. Core. That is center of the place. Uranium is kept, and uranium should travel in the neutron should travel with the specific velocity, same velocity or specific velocity. If the velocity changes, immediately it will not hit the neutrons. It will not hit the uranium. So its velocity is given as, so what I give?
Mu c equal to qb
Ah.
divided by 2 pi m.
Yeah. Nu c is equal to nu. But what is nu c? What is nu c? Huh? What is nu? Nu c? Frequency. Frequency of neutron. Neutron or neutron or just frequency is sufficient. Nu c is frequency. Because you need not keep for neutron. See, for nuclear power plant I am taking neutron. For some other purpose also I can use frequency of the particle. Frequency of the particle. And what is Q? Charge. And B is
Magnetism.
2 pi m. M is Yeah. Then magnetic field due to
Linear and circular.
linear and circular. Okay. So what is the formula I gave for linear?
B equal to mu 0 by 4 pi
Uh,
ID
I dl sin theta by r square. Where nu 0 is the permeability, I is the
current
current, dl is the
length
length.
mini
Length sin theta by r square. R square is the
distance.
distance. Yeah. Now in the circular loop, mu 0 is equal to
IR square
uh,
divided by 2 x square plus r square 3 by 2 power 3 by 2.
power 3 by 2. So it is what is the r here?
Radius of the circle.
Circle. A small x square is what is x square? What is x square plus r square? No.
Yes, sir.
X square plus r square whole 3 by 2. Okay. What is r? R is the radius of the circle. X is the distance between the magnetic field and the current. X is the distance between the magnetic field and the current. Okay. Then
Tag on the
huh?
ampere
Ampere
circuit law.
Ampere circuit law is given by B is equal to
B is equal to mu 0 I divided by 2 pi
2 pi r. So where I is the current, R is the
radius.
radius. Then
Solenoid
solenoid
and
and toroid. Solenoid and toroid. As what is solenoid? B is equal to mu 0. What is a solenoid? Did I give the definition? Definition. What is solenoid?
The length is very much greater compared to its radius.
Then toroid.
It is a hollow circular ring
Hmm.
on which large number of turns of wire is closely wounded.
Wounded. Okay. Then what is it? Next, force between the two parallel current. Force between the two parallel current. So it's given by FAB is equal to mu 0 IA IB divided by 2D. Torque on the first one is what you said? Force between the two parallel current. Then torque on the current loop. The torque on the current loop says that when the torque on the what is the torque? What is torque? Yes, circle only. That how will you tell? It's a type of angular momentum. What is the linear angular momentum? Circular angular momentum. Linear and circular. Linear angular momentum. What is angular momentum? No, angular momentum. Mass into acceleration. Force is equal. What is force? No. Angular momentum is equal to force into
Mass or
distance. Force angular momentum is force into distance. What is angular momentum now? That is a linear angular momentum. What is torque now? Torque is torque is theta. No, torque is not theta. Torque is equal to that one is a linear angular moment. Linear angular momentum is force into distance. Here torque is equal to Force into distance, similar to that. So that's a linear angular momentum, is a circular angular momentum. What is this value given by?
F1 equal to I small b capital B.
So F1 is equal to then
F2 equal to I small b and capital B equal to F1.
F1, okay. So total value is given by torque is equal to force plus F1 plus F2 torque. So torque is equal to IAB sin theta. IAB sin theta. Then yeah, galvanometer. Galvanometer, what is the purpose, you know? What is the purpose of galvanometer? Huh? Measure the current as well as voltage. Both it can measure. What is ammeter? Only current. It cannot measure voltmeter. It cannot measure the voltage. Then what is voltmeter? Only voltage, no current. But galvanometer can measure both current and voltmeter. So did I give equation? No?
Yes.
What equation? Phi is equal to by into I. What is I? What is the N here?
Number of turns.
A? Area. B?